So this F test is required whenever we wanted to compare the variances of different populations. So suppose you have two different populations, one having the variance as sigma 1 square, another having a variance of sigma 2 square. From this first population you take a sample 1 having n1 number of elements and s1 square as the variance. From the second population you take another sample having n2 as the number of elements and s2 square as the variance of that sample. So in that particular case we shall use this F test in order to determine the variances. So the question is why this test is required. This test is required because suppose let me explain you this with an example. Suppose a manufacturer wanted to make a product which meet certain specifications. So that means the consumer has defined that your product should be this, this and this, some kind of specifications. So in order to meet that specifications, he would have to perform tests which would check how much variation is there from the ideal product. So suppose this is the ideal product, his product, how bad is it, right? Or how more good it is from the ideal product. This is the ideal product. So he would have to check the variance for that particular product, and in order to check the variance of that particular product, he would have to apply the F test. Now, for this F test, we assume that these two samples have been taken from two populations which follow the normal distribution, and moreover we assume that the variances of these two populations that is equal to each other. So here what is F test? So F test is defined, the statistics for F, that is defined by dividing the variance of the first sample with that of the variance of the second sample. So this is the F statistics. So this would be the calculated value for F. And what are the degrees of freedom here? The degrees of freedom would be n1 minus 1 for the first case, where n1 is the number of elements present in the first sample, and n2 minus 1 for the second sample. So here we have 2 degrees of freedom corresponding to a single test F. So here how do we formulate the hypothesis? So your null hypothesis would be formulated whenever you say the variance of both the samples that is equal to each other. So this would be your null hypothesis. For the alternative hypothesis, we again have 3 cases. In the first case, we say that the first variance is greater than the second variance. In the second case, we say that the second variance is greater than the first variance. So that means first variance is less than the second variance. And in the third case, we say that none of them are equal to each other, right? So we check the inequality in this case. So these are the conditions that you may have. The null hypothesis would be fixed in every case. So this is your null hypothesis. For this alternative hypothesis, how do we test our how do we perform this F test, and how do we obtain the tabulated value, whether it is a one-tailed test or is it a two-tailed test? So in the first case, when the variances are less than 1, the variances of first sample is greater than the variances of second sample, in that case we say we compute our F using the statistics S1 square by S2 square, and this is your calculated value. So we compute this calculated value and compare it with the value F alpha with the n1 minus 1, n2 minus 1 degrees of freedom. So first degree of freedom would be corresponding to first variance, and second degree of freedom would be corresponding to second variance. And alpha, what is alpha? Alpha is the level of significance. So this is in the first case. For the second case, what do you have? In this case, you compute your F by reversing the order. So that means here it would be s2 square divided by s1 square instead of s1 square by s2 square. So this would be the calculated value of f, and corresponding to this your tabulated value would be f alpha n2 minus n1 into n1 minus n2. So that means the role of 1 and 2 have been reversed in this particular case. So here we will write the degrees of freedom for the second sample, and here we will write the degrees of freedom for the first sample. So in this case, this is the case. So we say in the first case we reject the null hypothesis, we reject h naught whenever your f is greater than f alpha n1 minus 1 n2 minus 1. This is for the first case. For the second case we say we reject h naught whenever your f is greater than f alpha n2 minus n1 n1 minus 1, and in the third case whenever they are not equal, first of all you calculate your f by calculating sm square by s small m square. Now what is sm? Capital M represent for large sample, small m represent for small sample. So a sample with size lesser would be divided in the denominator, and we will write in numerator whenever the sample is large. So it would be the variances like this. So this would be the calculated value. According to this calculated value, you will now compare it with alpha by 2, because this would be two-tail test. So whole of your region would now be divided into two portions. So it would be alpha by 2, the degree of freedom for the larger sample and the degree of freedom for the smaller sample. And in this case, we reject h naught whenever your f is greater than f of alpha by 2, n m minus 1 and n small m minus 1, right? So this is how you will perform this test. So tomorrow we'll see some examples related to this, so you will understand this test in a better way, right?